Observe these real-life situations. Joe and Alice have both come to City Store. Joe buys 3 cricket balls of the same price for his upcoming match by paying an amount of ₹60 to the shopkeeper. What price do you think Joe paid for each ball? We can mentally work out the steps, but for actual computation, it is more convenient to use algebra. Let us denote the price of one ball as ₹X. So, 3x is equal to 60. Solving for x, we get price of each ball as equal to ₹20. So, Joe pays ₹20 for each ball. Alice buys a doll and 3 hats for ₹120. Find the price of the doll and the hat. Let us denote the price of doll as x and the price of the hat as y. Using the facts, we can form the equation x plus 3y is equal to 120. Consider this as equation 1. But this does not help us in getting the price of the hat or the doll. There may be many combinations of x and y which can satisfy this equation. Why were we able to find the price of the ball but not able to find the price of the hat or the doll? In the first case, we had one unknown represented by one equation, so we could find the value. But in the second situation, we have 2 unknowns and one relation between them given by the equation x plus 3y is equal to 120. So, we were not able to find the value. What is required to solve the second scenario? We need another relationship between the 2 variables x and y. If we get another fact that the price of the doll is equal to the price Alice paid for 3 hats, this can be represented as x is equal to 3y. Consider this as equation 2. Now, substituting equation 2 in 1, we get 3y plus 3y is equal to 120. Or 6y is equal to 120, or y is equal to 20. Substituting the value of y in equation 2, we get x is equal to 3 into 20, that is equal to 60. So, the price of the doll is ₹60 and the price of the hat is ₹20. Each of the equation 1 and 2 is of the form ax plus by plus c is equal to 0, where a, b and c are real numbers and a and b are not zeros. This equation is called a linear equation in 2 variables x and y. Since both the equations are in the same variables x and y, they are called a pair of linear equations in 2 variables. The value of x is equal to 60 and y is equal to 20 is a solution of the pair of linear equations. The general form for a pair of linear equations in 2 variables is a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0, where a1, b1, c1, a2, b2 and c2 are real numbers and a1 square plus b1 square is not equal to 0 and a2 square plus b2 square is not equal to 0. Let us take a look at the pair of linear equations from the last example again. X plus 3y is equal to 120. X is equal to 3y or x minus 3y is equal to 0. We will now plot these equations on the graph. Let us take the first equation x plus 3y is equal to 120 and compute different values of y for different values of x and tabulate the same. We plot the corresponding points on the graph. What do you observe from the graph? We observe that the graph of a linear equation in 2 variables is a straight line and the point 60, 20, which is the solution we got, lies on the line representing the equation x plus 3y is equal to 120. Geometrically, we can say that every solution x, y of the linear equation in two variables ax plus by plus c is equal to 0 corresponds to a point on the line representing the equation. Now, let us tabulate the values of x and y for the second equation, x is equal to 3y. To find this out, let us plot the points corresponding to the second equation also. We observe that the two lines representing the two equations are intersecting at a point, and this is the only common point. What do you infer from this? When two lines intersect at one point, then there is only one solution. That is, this pair of linear equation has a unique solution and is also called a consistent pair of equations. A coach of a cricket team buys 2 bats and 3 balls for Rs 900. Later, he buys 4 bats and 6 more balls of the same kind for Rs 1800. Represent this equation algebraically and geometrically to find the cost of a bat and a ball. Let us denote the cost of one bat as Rs x and the cost of one ball as Rs y. The algebraic representation is given by the equations 2x plus 3y is equal to 900, equation 1. 4x plus 6y is equal to 1800, equation 2. Geometrically, can you say how this pair of linear equations would look like? To obtain the equivalent geometrical representation, we find 2 points on the line representing each equation. That is, we find 2 solutions for each equation. The solutions are tabulated as follows. Plot these points on a graph paper and draw the lines. We observe that both the pair of lines coincides at all points. Look at the equations carefully now. Can you find out why the lines coincide at all points on the graph? Divide the LHS and RHS of the second equation by 2. We get 2x plus 3y is equal to 900. So, both the equations are equivalent, that is, one can be derived from the other. When two lines coincide at all points, then the pair of linear equations have infinitely many solutions. This also means that it is a dependent, consistent pair of linear equations in two variables. The air route from Bangalore to Chennai is represented by 2x minus y plus 9 is equal to 0, and the air route from Delhi to Kolkata is represented by 6x minus 3y plus 10 is equal to 0. Let us represent this situation graphically and find its solution. Here, the air route from Bangalore to Chennai is represented by linear equation 2x minus y plus 9 is equal to 0, and that from Delhi to Kolkata is represented by the equation 6x minus 3y plus 10 is equal to 0. The solution to each of the equation is tabulated in the table given below. Now, we plot the respective solutions of the two equations to graphically represent the two pairs of equation. What do you infer from the graph? We observe that the lines do not intersect anywhere, that is, they are parallel. This also means that the two air routes never coincide or converge. Thus, when two lines are parallel, then the pair of linear equations has no solution. It is an inconsistent pair of linear equations in two variables. Now, let us summarize the pair of linear equations formed by all the three situations and write down the kind of pair they are geometrically. Let us find out if there is any relation between their coefficients and the geometrical or algebraic interpretations. To do so, we start by finding the ratio of their coefficients. Let us write down the value of a1 by a2, b1 by b2 and c1 by c2 in the table below by comparing the pair of linear equations to their standard form, which is What relation do you observe between the ratio of their coefficients and the graphical representation? Here, we observe that when a1 by a2 is not equal to b1 by b2, that is, the pair of equations has a unique solution or is a consistent pair of equations. Take the second set of linear equations in two variables. We observe that a1 by a2 is equal to b1 by b2, that is equal to c1 by c2, in the case of a pair of linear equations which has infinitely many solutions or is a dependent, consistent pair of equations. In the third set of a pair of linear equations which has no solution or is an inconsistent pair of equation, we observe that a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. Let us summarize the ratio of comparing the coefficients, its graphical representation, and its algebraic interpretation for the different pairs of linear equations. So, given a pair of linear equations in two variables, we can find out the type of solution the equations will have by just comparing the coefficients of the two equations without any calculations or plotting on the graph. A pair of linear equations in two variables with the standard form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Intersect if a1 by a2 is not equal to b1 by b2. Coincide if a1 by a2 is equal to b1 by b2, that is equal to c1 by c2. Parallel if a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. Find the value of k such that the system of equations 3x minus y minus 5 is equal to 0 and 6x minus 2y minus k is equal to 0 have no solution. Here, the given pair of linear equations are 3x minus y minus 5 is equal to 0 and 6x minus 2y minus k is equal to 0. Comparing the coefficients with the standard form of linear equations, we get a1 is equal to 3, a2 is equal to 6, b1 is equal to minus 1, b2 is equal to minus 2, c1 is equal to minus 5, and c2 is equal to minus k. We know that the condition for pair of equations to have no solution is given by a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Substituting the coefficients in the above equation, we get 3 by 6 is equal to 1 by 2 is not equal to 5 by k. Or 1 by 2 is not equal to 5 by k. This implies k is not equal to 10. Thus, for a pair of linear equations, 3x minus y minus 5 is equal to 0 and 6x minus 2y minus k is equal to 0 have no solutions. The value of k cannot be 10.